Good afternoon, everyone. Welcome to the knowledge session. So today's session will be on RBAC and Kuberetes. And this session will be delivered by Nishwani. I'm working as a software consultant here at Nordis, along with Suraj, who is also working as a software consultant here at Nordis. So first, let's walk through the knowledge etiquettes. First is punctuality. Respect the knowledge session timings. You are requested not to join the sessions after a 5-minute threshold post the session start time. Please provide your constructive feedback. Please make sure to submit the feedback for all the sessions, as it will be very helpful for the presenter. Next is silent mode. Keep your window on mute. And please try to avoid disturbance. Avoid all the unnecessarily unmuting of your windows and keeping it that way. So moving ahead, this will be the agenda for today's session. First, we'll discuss about what RBAC is, RBAC in Kubernetes. Then what is the need of RBAC. Then we'll go through the benefits of using RBAC. Obviously, what benefits do we get by using this certain policy. Then we have the implementation of RBAC followed by a short demo. So starting with RBAC in Kubernetes. But before that, I would like to talk about what RBAC is in our daily life. What is the impact of RBAC in our daily lives? Right. So this is basically just imagine a scenario that in an organization we have different departments, and we have individuals working in different departments. So we have a flavor, like variety of individuals or employees working there in those departments. So like we have a HR department, we have a finance department, we have engineering department, sales department, and so on. So now consider a scenario where like an employee from a sales department should only be allowed to access the customer database. He should not be worried about what's the payroll for each employee in the organization, or what is the code base for the software that they are trying to sell in the market. They should not be able to access the other domains, but they only should be restricted to their own domain, so that they do not hamper the work that will be done by the other individuals belonging to the other domains. So similarly, like in a finance department, so we should have an employee who should only be able to access the payroll database for all the employees in that organization, and should not be able to hamper the work of a software engineer by making some minor changes to your code base, which can go on production and which can cause which can cause harm to the software or the deliverables that we are running in our organization. And similarly, a software engineer should not be worried about the user database that we are storing in our organization. The HR department employee should not be worried about what is basically the tech stack that we are running, or the code base or the changes that we are running inside our projects. So in order to avoid a person from a particular department to accidentally create some changes or to mess with some of the files in some other project belonging to some other domain. So in order to avoid this kind of a situation, we basically require access control policy in order to restrict the users from basically using or trying to change some other projects or some other files, some minor changes to some other files. So this brings out the need for access control policy in order to restrict the users. So this is how we have implemented RBAC in our daily life. So how will we be using RBAC in Kubernetes? Right. So what RBAC is? RBAC is basically a role-based access control mechanism. Through RBAC, we are trying to regulate, we are trying to permit some access to some users within an organization based on the requirements, based on the roles they have to perform. So it's a method of regulating access to some network resources based on the roles of the individuals which are there within the organization. Next, what RBAC does is RBAC is used by Kubernetes for authorization. See, if I have a team of developers, basically a project in which we have like flavor of domains that we are using. We have some backend developers, we have some front end developers, we have QA department, then we have a DevOps engineer, and many more. So now I want to give permissions to the users based on their job profile. A backend developer should only be able to access the database and the services they are working upon. And similarly, a front-end developer should only be able to access the front-end modules of those services. A DevOps engineer should have the cluster admin rights, maybe. This is just an example. A DevOps engineer would be dedicated in maintaining the cluster resources and adding or removing some permissions and so on. So this would be used, RBAC is used by Kubernetes for authorization. So with this, we are granting access to users or maybe applications that are running in our cluster. And we can add or remove permissions, or we can even set up some rules. So this is a small use case where RBAC is used. So how RBAC is working? RBAC is trying to provide a security layer to our cluster. A person outside the organization or outside the project cannot access the resources of our cluster. He cannot mess with any of the resources. He cannot create or he cannot even delete any other resources. So we are providing a security layer to our Kubernetes cluster. And RBAC in Kubernetes is a way that you can restrict who can access what within your cluster. This is very simple to understand. A user can be allotted a specific role according to his job profile, and according to those roles, he can access only the limited resources that we have allotted to him inside the cluster. It can be inside the cluster or even for the cluster. Moving ahead. So what is the need of RBAC? So I explained this earlier as well. So if you have a team of maybe 10 people in your project, so you have multiple variations of departments, like people belonging to some front-end developers, some belonging to DevOps, maybe some belonging to data entry team, or there are many. So this brings out a call for a security from one another, that a person who from a team cannot interfere with some other member's work. Even accidentally, he cannot delete someone else's work. For example, there is a file named as A. A person, developer 1, came and made some changes to it, and mistakenly a developer 2 comes into the picture and he updates that file. But that can create a chaos in your project, because you don't want the files of one person to be affected by the other person. So we are trying to provide a layer between as a security layer in the project, so that no other person can gain visibility into a project that is maybe under development or that has some work done on production which has not to be changed. So this is how RBAC comes into the picture, because RBAC, as the name suggests, role-based access control. It is providing you some set of permissions to a certain individual, and only based on those permissions he can gain access to your resources. So this is very important nowadays in order to implement security. And yeah, that is it. Then next we'll be discussing about the variations, like what happened before RBAC and what happened after RBAC came into the picture. So before RBAC, as you can see, we have users, individual users by the name of user 1 and user 2, and we have a group of users. So I'll explain the group first. A group of users is basically a team of certain individuals who are basically requiring the same set of permissions on your cluster. You don't want to grant individual permissions to 100 users, the same set of permissions to 100 users, but you want there should be a group. You allot those permissions to that group, and those users become a part of that group. So this is basically saving your time, saving the extra work that has to be done in order to grant from permissions to individual users. Then, as you can see, you have a Kubernetes cluster here. So we have certain different resources, like we have pods running, we have services, we have deployments, replica sets, and so on. There are so many resources running in your cluster. now you want, like before RBAC, what used to happen was a user 1 has access to all the resources, and similarly user 2 has access to all those same set of resources. So any changes that have been done by user 1 can easily be overwritten by user 2. He can get an access to those resources, he can read, he can write, he can update any thing that he wants in the configuration files, so as to create some other deliverables mistakenly maybe. But yes, so this was basically a breach of security, as you can say it like that. So here the user 1 had a complete access to your cluster resources, and thus he can affect the work of other users, or maybe a group of users in the same namespace, or maybe in different namespaces. What namespace is, that this we will discuss later in the future slides. But for now, we can understand namespace as like you are creating a small set of virtual clusters inside your main cluster, the Kubernetes cluster. So you are basically dividing resources to certain groups, and like those groups you are calling them as namespaces. Like this certain namespace can has a resource limit of this particular amount, and the other namespace has a resource limit for this particular amount. So this is how you can distribute your resources consumption amongst your clusters. So this used to happen before RBAC. So this was a very bad idea. Yes.
Okay, I have a question here, but before RBAC, couldn't we just set policies on Kubernetes cluster and use attributes to restrict users?
Sorry, Shubham, I cannot understand clearly.
I'm audible?
Yes, you are, but there is a disturbance from your side.
Oh, okay. Let me just post it in the chat section. Hold on a second.
Okay.
Shiva, I think you can continue. Yeah.
Okay, so we'll take up these questions a bit after this. Okay. So yes, so before RBAC, this was a very bad idea, because everyone is getting the admin access rights. Like you also get an admin access right, and the other person also is getting the same access rights. So there would be a chaotic situation here. So what after RBAC, what came into the what happened was, like now you have the same set of users here. The group is there, but now you have defined certain roles to them. You have some designated roles, and based on those roles, the user can perform actions on your Kubernetes cluster. Like each user or a group of users, they have certain permissions allotted to them, and based on those permissions, they can perform some actions. They can either get those resources, they can list the resources, watch, they can create, update, patch, and so many other actions that can be performed. So this basically helped us in bringing out the access mechanism here. So the user 1 will not now be able to like make changes to the work that has been done by user 2, or maybe like the other group of users. So this was how RBAC helped us, because it helped us in designating certain permissions to the users and how the resources will be used up based on those permissions. Moving ahead. So we'll discuss what are the benefits of using RBAC. So RBAC will help us in like it will have multiple users with different properties following a proper authentication mechanism in order to access the resources. For example, we have certain user by the name of, let's say, Abhinav, and he can access the resources, like one of the resources for which he can have the read and write permissions, and for some other resource he can only have the read permissions. So it brings out the flavor, it brings out the variations a single user can have, and similarly for multiple users we can follow this in a similar pattern. And yes, this is the way they will be now accessing the resources, like only those resources that they have been assigned to use. And it also helps us in gaining a full control over which operations each user or group of users can execute. Yes, so basically we have certain types of users here in Kubernetes. So we have normal users, and for this, we have like individual users or a group of users. We can create a group designated and for like certain action that has to be performed, and all the users that will require the same set of permissions can be added to that particular group. So we can control like what operations and in what manner they can perform actions on in the cluster. Similarly, we can have a full control over which operations each process inside a pod can execute. So what do I mean by process? So we have this was the second point that we discussed about, was just for the users. Now, if we talk about the applications that run inside of a cluster, so we can even designate those applications, the processes that are running inside our pods. So we can designate them that they can be allowed to use this much set of resources, or this much amount of, like for example, the CPU or the memory limit should be this, that can be accessible by this particular process, or we can assign that this can create new pods, this can delete new pods in a similar fashion. So yes, so this is how we can gain control over the actions or the operations performed by users or the processes. We can limit the visibility of certain resources of namespaces. Yes, so inside a Kubernetes cluster, we have designated namespaces for different actions, for different environments, I should say. We can have a namespace completely for a dev environment. We can have a namespace designated for a QA environment, and so on. So inside a dev namespace, we can limit the visibility of certain resources, right? So if I have inside a dev environment, I have backend developers as well as front-end developers. So I need that the backend developers should only be able to access this much amount of resources and in this fashion. But the the front-end developers should now be able to access the other remaining resources and in some other fashion. Maybe like they can only be allowed to list, they can only be allowed to update. But so this is how like I can limit the visibility of resources inside the namespaces. Also, an individual who is belonging to certain namespace cannot access the resources of the other namespace because he doesn't have the permission to do so. So this is how we are implementing like authorization and a sense of security here in our cluster. So this is like a few benefits of RBAC. So yes. And now we'll discuss about the steps to implement RBAC. How can we implement role-based access control? So you must have heard like me saying namespace a lot many times. So firstly, we need a namespace for this because we are creating roles for certain users, like the permissions that that will be allotted to certain users. So I need a namespace for that. Okay. So then next, I need users or like a group of users. So I have to create certain users to whom I will be allotting permissions, like who are designated to work in this cluster and in what manner. And if we are not talking about people here, so if we are just talking about the applications, so in case of applications, we will be creating a service account for the same. Next, now we have the namespace ready. Now we have the users or the service accounts ready. But now I need to set ground rules, like the set of permissions that will be allotted to those users, like in what manner they will be able to access the resources of my cluster. So if like I just want to give them or grant them the access to watch the pods and not perform any other action, like they should not be allowed to create any resource, or like they should not be allowed to delete any existing resource. So I can create some ground rules for them. So for that, we have to define a role. And now we have roles set up and we have the users or the service account set up. But how should I connect these two? So in order to connect these two, I need a role binding. So what role binding does is it will bind a role to a certain user. Like this particular individual can only perform this set of permissions that are mentioned in this role. So role binding is used for those purposes. And after you have everything set up, then we'll try to access the cluster. Then we'll try to test our permissions that we have granted to the cluster. So these will be the steps that we'll implement in RBAC. So first, let's discuss what namespaces are. Namespaces are some Kubernetes objects which allow you to partition your single Kubernetes cluster into small virtual clusters. Right, so you have certain resources belonging to your cluster. For example, I have X amount of memory available to this particular cluster. But now I want to segregate that between like different groups. Like the backend team should be able to access certain amount of memory or like resources. The other front-end team should be able to access this much amount of memory. So I can partition that with the help of namespaces. I can create certain groups inside my cluster, like virtual clusters. So yes, namespaces are used for this matter. So this is a very generic information. Like in namespaces, you have to have a unique name for each of your resource, right? You cannot have a pod by the name of A, and you cannot have another pod again by the name of A running. You cannot start it with the same name. So for this, you inside a single namespace, you have to have different unique names. I should say, but that is not applicable to different namespaces. Like in namespace A and in namespace B, I can have a pod running by the name of A in both the namespaces. So this is how that namespaces help us. Now, if you want to create a namespace, you can just simply run this command: kubectl create namespace and then dev en. This is the name of your namespace that you are using. So yes, this is a small command that you can use to create a namespace. Okay, so first let's discuss how we will implement RBAC for a user. So all the Kubernetes clusters, they have two categories of users available. You have service accounts, which as I discussed, are for applications, and other than that, we have some normal users, in which we have some individual users and or a group of users. We can define it or divide it into these groups. So for normal users, we do not have certain like API objects already there for user accounts. So what we'll try to do here is like we'll use X.509 client certificates with OpenSSL to create a new user. So let's just move on to how can we create a new user. So the steps for creating a new user is, firstly, we need a private key for the user. Then we need a certificate signing request for that particular user. And after we have these two files ready with us, then we'll go for the certificate authority of Kubernetes. So for which will be used to basically like sign our certificate signing request, and then we'll have the certificate generated with us. So for this, I have mentioned the commands. We will go through them in the demo segment as well. So what command we'll have is OpenSSL gen RSA -out. We have given the name of the key as opanshu.key, and then it's 2048. So what everything here is like with the -out flag, we are instructing that the file that has to be generated is it should be by the name of opanshu.key. And the size of this should be 2048, which is the size in bits. Next, we'll have the certificate sign request using the private key. So here again, we have the command as OpenSSL request REQ, then -new. Then again, we're specifying the key opanshu.key, then -out. Like this should be the file that should be created, opanshu.csr. And we have to mention the subject here as well. So for subject, we have /cn as opanshu, which is the username, and /o as developer. This is the name of the group. We specify the group here by this /o. Then locate your Kubernetes cluster certificate authority, which is responsible for approving your request that you are trying to give to your cluster, and it will generate the necessary certificates to access the APIs, cluster APIs. Okay, so this is usually present if you are using a minikube. So it will be present in your .minikube directory by the name of ca.cert. And similarly, if you are using any other cluster, so there you will have mentioned the ca.crt file present in etc's Kubernetes PKI directory. Okay, so for generating the final certificate, by approving this request, we use this particular command, OpenSSL X509. We are requesting, and the input file should be upanshu.csr and -ca. With this, we are like specifying the CA location of my ca.crt file. Then again, we are mentioning the location of the key file that I want here. And with the create serial flag, we are just giving it instruction that you have to create a new serial number for the certificate. And the output file should be by the name of upanshu.crt. And this file will be valid for next 100 days. So this can be changed. This can be given as per your requirements. So after generating the request, or like after getting a certificate, then the next steps would be to basically add a new context and setting the new credentials for your cluster. So you will be requiring kubectl config set credentials, and then you will be mentioning the username, which is here as Upanshu, and then you will be mentioning the client certificate, the location of that certificate, and the key. Next will be like kubectl config set context. Again, the name of your context, and you will mention that what is your cluster. Here it's Minikube, and then you will mention the namespace that you created earlier and the username. So after like generating or like running all these commands, at the end you will have a user by the name of Upanshu created, and it will be existing in the developer group, and his context is also set. So quickly running through like what roles, role binding, and everything is. So roles, what roles are? Roles is basically a set of permissions or like rules that we are setting for the resources to be accessed in the particular namespace. So there are two types of roles. If you're just going with the namespace, then you'll just use the role. And for like next, if you are like giving permissions for your complete cluster, you will work on cluster role. So yes, then we'll have role binding. We'll explain this YAMLs in the demo segment. So I'm just I'll just give a brief introduction to what the concepts behind these are. So role binding is basically like connecting your roles with your users. So this helps you bind the roles with your users or maybe service accounts that you're using. So based on the types of roles, we have role binding for namespaces, and similarly cluster role binding, which would be for like cluster roles and your users to bind these two. For applications, we have YAMLs again created here. So we create a service account for applications. The pods that have to interact with the API server, they will authenticate themselves with a service account first. So this is how authentication comes into picture here. Then again, the role is like a set of permission within a particular namespace. Again, this is the role binding that we'll use for the service account. Suraj will explain this much better. Like here, we have the kind here as service account, but for the roles and like where we want to create a user or a group, so we'll have the kind here, there will be as user or a group, and defined by the name and the namespace they belong to. So this is what role binding is. This is granting permissions to a user or a set of users based on the roles that they have been attached to. So this will be a case study which we can quickly go through after the demo segment. Suraj, can you please continue after this?
Yeah, thank you, Shivani, for the wonderful explanation of all the topics. I guess they are very clear as no one is asking questions.
Yeah.
Except Shubham.
Okay. Can you please start with the demo?
Yeah, I'm sharing this.
Yeah,
I'm sharing my screen. Okay, is it visible now? Just let me know.
Yes,
yeah,
it's visible.
Okay. So our first steps involves the creation of a user. So we'll be using OpenSSL here. So as Shivani has already, let me zoom it a bit further. Yeah, as Shivani has already explained how these commands work. So I'll be just creating a user. So I would like to add here that here 2084 is the length of the key. So we can basically use it accordingly, like 5112 or 1024 or any of that. Next, we'll be creating the key for the CSR for the Upanshu user. So here the point to notice for the username we have to use CN here, and to specify the group. Let's say as Shivani has mentioned that if group if we can basically create a group of multiple users and attach all the required user with that group. So instead of and this can be followed instead of creating a separate user and attaching and creating a role binding for separately for each of the user. So we'll see that part in the upcoming demo as well. Okay. Yep. So okay. And similarly, now what we'll do is, so we will basically use the signing authority of the Kubernetes. So currently I'm using Minikube here. So wait, there is a, yeah, I have to update it. So for the Kubernetes cluster, I'm running my Kubernetes cluster on Minikube. So the location for that would be inside my Minikube and CIF, that would do. And similarly, and if you are running your Kubernetes cluster somewhere else, like apart from the Minikube cluster, so in your master node, you will be able to find this particular files under the etc, then the Kubernetes folder. Okay, let me update this as well. And there are days 100, as it is self-explanatory that the certificate will be valid for the 100 days. Yeah, okay, now it is created. Okay, so now the user has certificates and the private key for the user has been created. So now we will make changes in our kubeconfig file so that our Kubernetes cluster actually starts to means recognize the user. So for that we have to set the make some changes in the config file. So yeah, and similarly. Okay, so what these two commands actually did is, so let me show you the config file of the Kubernetes. So where it is, in my kube and conf. Yeah, so there it is. Okay, so here I think it is visible. Yeah. So this is the actually the config file. So config file, basically we have information about the clusters. So here we can see that cluster authority, where our cluster authority lies, so the path can be grabbed from here as well. Then the server where our Kubernetes server is actually running, then the name of the server, and the following are the information. So what we actually did here is, so first of all we set the credentials for the Upanshu. So by these command we are actually creating a user here. So as you can see that now I have a user such named as Upanshu, and this is his certificate and the private key for him. So instead of running this command, we can actually come here and we can actually update this particular file from the from by using any of the text editor as well. So that will also do. Then in the next step, or in the next command, what I have done is I have basically created a context. So context is basically the there can be multiple contexts for the Kubernetes cluster. Like let's say we can have multiple users. So here I have a user named as employee. Then there is a default user of the Minikube, and the new user which I have created is Upanshu. So context basically specifies that I'm accessing a cluster by with a specific user. So that actually specifies the context. And so yeah, now it's done. And now let's quickly test the status of the cluster Minikube status. Okay, now it's running. So okay, so now the user has been created. Now I haven't created any role or anything related to the user. So let's quickly test whether that particular user actually can do something or not. So for that we'll use the kubectl command. So here kubectl command is basically tool which we are using to basically interact with our Kubernetes cluster. So I'll be using I will be first setting up the context to and the name of the context which I have just created. So name of the context is Upanshu context. Let me grab it from here. Yeah, and let me try to get something. Or let's say let's get pods. Okay, there is a. I think there is an error. Okay, I have submitted it wrong. So basically, I have to rectify it.
Suraj, can you
Yeah.
remove the dot search? Yes.
Wait, let me edit this file as okay. Here I have specified the wrong this. By default, it will create in your that it is the default location. So I have created the user and the key and the certificate at this particular location under the DevOps knowledge and RBAC. So that's why it's showing this error. Let's try to
Suraj, can you just open it again? The file.
wait.
Yes,
Yeah.
you missed a slash there. RBAC. After RBAC,
Yes.
just in the second last line,
Mhm.
after RBAC, just add a slash after RBAC. You have it mentioned like before Panchu.crt.
In the client
Okay, sorry.
certificate section.
Yes.
And anything, I guess we have put it. Okay. So we can basically try doing it again. Okay, pods if, or let's say if I, yeah, get pods. It would take a moment. Yeah, okay. So we can see that it's a perfect message as expected. So the it is the user Upanshu cannot list the resources because we haven't specified any rules or we haven't created any rules for it. So let's create a role. So as we all know that okay, so I'm using here Upanshu to give the examples related to him. So as we all know that he is a developer, so and he is currently working in the Ultimate project. Okay, so for that, let's for the example create a namespace first of all. CTL create this Ultimate. Okay, so as the Shivani already mentioned that namespaces basically create virtual partitions in the same Kubernetes cluster. So instead of having multiple clusters, we can actually create logical partitions and multiple teams can actually work in different namespaces without conflicting each other. Okay. Okay. So now we'll create a role for the for a developer role for the namespace Ultimate. So any of the developer that is working under Ultimate will get these roles. So here we have certain rules defined. So there are three main things inside the rule, that is API group, resources, and works. So we have basically four API groups, that is core, extension, apps, and the networking. So and it's and if you leave blank, it will automatically take core API as a part of it. So pods comes under the core API part, and let's say deployment and replica sets are under the apps part. And here the verbs basically specify the action that actually a particular user with the role can actually perform on this particular resources. So here, as we can see that get, list, watch, create, update, and all these are the stuffs that a user with the role as developer role can perform on these particular resources. So let's create this developer role. CPL apply and the developer role Prokian. Okay. So now the role is created. So and similarly, this I have used as kind as road. So there are two types of role basically. One is simply a role, and second one is a cluster role. So if you want to specify or give particular action that actually a user can implement throughout the cluster, so in that scenario, we should be using a cluster role. So simply we can just add a cluster over here to create a cluster role. Then to create a role binding means how the Kubernetes cluster will come to know that we have to, these roles are binded with a particular user. So we can actually do that with role binding. And similarly, there are two types of role binding, a simple role binding and a cluster role binding, with the counterpart as defined the cluster role part. Okay. So here we have specified some metadata and the namespace. And in the subjects part, we have defined that the kind is user. So there can be three kinds: user, group, or a service account. So user is basically, it signifies the individual user. A group will specify the basically more than one user or the group in which we have created. So let's say we have created a group as dev group. So we can also use that. And the service account basically is used when we are doing this, or we are implementing this RBAC for the application part. Yeah. And then we have the role reference, like which role you have to use. So you have to use a role named as developer role, so which we have just created. So this will create a role binding for us. Okay, so now the role binding is created, and we have already attached this particular user Upanshu with the roles, and here are the roles. He can basically perform all sort of tasks which is mentioned here. So let's try listing pods or getting pods from the context. Okay. Yeah. There's a let me check it. So, yeah. Okay, I have specified role as, let me change it as alternate. It is there, not less box. Wait, let me check it. Space. The road is there. Okay. So here's the another stuff. What we can do is we can actually take the help of the UI. Minikube. There is a beautiful dashboard which Minikube offers. Yeah, okay. Namespace, you can choose ultimate until let me try it again, or we can test it in the other manner which we have the detail, the auth-cani command. So there is a sub command which the kubectl also offers. Kubectl auth can I, and we can say that create pod. Okay, we can test for this first. Create pod. Then in the namespace, I have n ultimate. We will here ultimate, and the user is as function. Q. Okay. Yeah, I have to specify double. Okay, so now it says that you can actually access the, you can basically create a pod, And so here, which verbs which I have specified. So basically, he can do all this stuff with the pods. And if I let's say remove this particular thing, delete. Okay, and just apply it again. Yeah. Okay. And now if we test it, like if he can delete a pod, so delete a pod. So no, as it says no. So because these rules are purely additive in nature. So basically, if you list put something a particular verb here, so that means a user can actually perform that task. And if it is not there, so that means no, the user cannot perform this task. So yeah, so these are the steps to implement RBAC for a particular user. So inside a namespace, and if we have to do this for the application part, so for example, I would like to mention Helm. So I think most of us will be familiar with Helm. So Helm is basically a tool which can be used over Kubernetes to install various applications. So basically, instead of installing a single multiple YAML files one by one, what we can do is we can actually group all those YAML files inside a particular chart. So chart is a term which is used in the Helm. So it's basically the terminology used to basically refer the directory structure. So inside that you can put all your YAML files, and with a single command you can basically install or deploy all the resources which you want to create in your Kubernetes cluster. So Helm basically, if we talk about Helm 2, so it basically uses two components. The first one is Helm component, which is a client side component, and second is the tiller component, so which is actually a server side component, or basically it is installed, it actually resides in the Kubernetes cluster only. So this tiller is actually responsible for creating all the YAML configuration files for us. So it will basically deploy. And while working with tiller, so there are scenarios in which the tiller is not able to make a particular resource, or it is not able to delete a particular resource. So instead of doing that, what we can do is we can actually create a particular service account with the tiller. So let's say we have a service account named as tiller service account, and namespaces cube system. So why the namespaces cube system? So cube system is the main namespace where the all the pods or the resources related to the cluster resides. So the tiller components also resides in our Kubernetes in the cube system. So let me show you the what are the namespaces we have. Get ns. So what we can do here is, so we can attach a service account. So if we implement RBAC for the users, we can simply create a user and do this stuff. And if we want to implement RBAC for the applications, so in that scenario we have to use the service account. Then similarly will be creating role the tiller can use. So here this star signifies that it can basically do all kind of actions which is required. Then similarly, we will be creating a tiller role binding. So here's the interesting part. So as I mentioned that in the subject, we can have value as user or a group or a service account. So if we are implementing RBAC, then we have to actually use service account for the applications for the application part. And here the name is the tiller, and the namespace is cube system. So because this tiller is deployed in the namespace as cube system. Then role can be specified as role, and the role which we basically created is tiller role, and this particular role can be specified in the role binding. So this will basically enable tiller to this will basically give the tiller all the permissions to perform these stuffs which is required. So let me show. Yeah, ultimate is there, and okay, and to basically use Helm, we have to basically perform a command known as Helm init, and for that we have to wait. First, we have to create a service account for that. So kubectl apply -f, and then the tiller service account again. Yeah, okay, that is created. So now if we initialize with init and we specify service account. Then we can specify the name of the service account, which is let me take it from here, tiller service account. Okay, now this tiller part has been means this application, basically the tiller, which has been initialized. So let's check at the tiller part. So as you can see that kubectl get auths and namespace view. Yeah, so it is basically creating a container for the tiller. So and now we are able to use any of the helm command after this pod has been provisioned here. So we can basically use any of the the helm commands to install our charts related to it. So why RBAC is needed for the tiller component? Because as previously I was working with the TM project, and there we actually saw many of the charts in which were failing due to the lack of the permissions in the roles defined. So basically, in that scenarios, we have to manually go and create certain roles for the tillers to use. So yeah, that can be used with the applications to implement RBAC. So I think it would take time. Okay, it is running. Yeah, and now we can actually do any of the stuff. Like, let me create a namespace first, or I can use the same namespace. Helm install name. I can do the nginx. We can do for the nginx demo. The code it is not. It's only 10 minutes are left here. Let's go search. Next. Okay, so here we have multiple charts for nginx, and then let's simply use this first chart. So nginx, and we can specify the namespace to use. So I have an namespace. ESE, and the name is ultimate. Okay, so what this command will do is, so it will basically install the chart for the nginx. So that is already available in the repository, and it will the tiller component which we have basically created, and we have basically created a service account and the rules. So the tiller will work only according to the rules which we have created. Wait, there is an issue. Okay, so here it is saying that a namespace ultimate is forbidden for the service account cannot get. Okay, right, so let me here role binding is there, correct? Is the tiller role. Okay, here we have to specify the yeah. So that would involve basically recreating it. I think we are less of time. So yeah, think we Can you see my screen? Yeah. So I think we are less of time, so I think we can close the session and ask the audience if they have any question for us.
Right.